Yeah, that's okay. Go live. I think we are live now. I'm just checking up on my YouTube window if the link has started streaming or not. 1 second. Yep. Cool. Hello. Give me just 1 second. Let's see if you guys are able to see everything. If my voice is audible, send a W in the chat. Okay. Send a W till I say no. Okay. I'm just testing if you guys are able to hear me or not. My audio should be crystal clear this time. Yes, good evening everyone. Just send a W if you guys can hear me, and I will tell you guys when to stop. Am I audible? Yep. Weird. None of you are sending. Okay, yeah, cool. You can stop sending W. You guys can hear me then. Thank you. That's all I needed to confirm. I'm just going to keep the comments section open here so that I can see what is getting streamed, and let me just go live here as well. Perfect. Cool. So I'm just going to put this thing where should I put it? Here? All right, yeah, let me just put it here. And let's start. It's 7:02. There are quite a few of you here, so let's start. Yeah, so as promised, this is going to be the second part of our robotics car tutorial. If you guys have not watched part 1, you can go to the YouTube channel and watch the first part. In the first part, we learned how to create, how to build your own line following robot. Sorry. Yeah. So we had attached motors, the batteries. We were using an Arduino, and we coded the logic of how to make a car follow a specific path, and we were using things called IR sensors that were able to tell our car where the line is and to follow the line. Yeah. So this is going to be part 2. Here, what we are going to do today is we are going to make our car not follow a specific path, but try to avoid any obstacles that comes in its path. Like I'm just going to change the scene here so you guys can see the car here. So I have a car here, you guys can see. This is the same car that we built in yesterday's session. In last week's session. Okay, and yeah, so this is the same car we built in last week's session, and what we are going to do today is you can see I have removed the IR sensors from here. So what we are going to do is we are going to be attaching something called an ultrasonic sensor. Okay, so this is an ultrasonic sensor, again as usual. So I'm guessing in the last video, in last to last week basically, we had listed out the parts that we were using, but we had not listed out where you can buy those parts. So in this week's video's description, right now it's not added, but I will once the stream has ended, I'm going to add. Guys, can you okay, yeah. So what we are going to do is I'm going to in this week's video's description, I'm going to add where you can buy all the parts that you are seeing today, okay, on the car. Each and every single part that we are seeing, we are going to I'm going to add a link of where you can buy all of those parts and how to use all of those parts. All right, so those things are going to be available in the video's description if you keep on checking there. Awesome, cool. So okay, so now as I was saying, we are going to create a car that can avoid obstacles. Basically, it means that it is not going to follow a specific path, it is always trying to, it will always try to move forward. Okay, it will always try to move forward. And then what we are going to do is, the moment, let me just check one thing here. Yeah, so my audio should not be echoing. Good. So yeah, the moment it faces an obstacle in front of itself, it's going to turn left or right by checking the distance between the car itself and the obstacle, and checking how much distance space it has on the left and the right hand side. Okay, so that is going to be the objective of today's session. Awesome. So now that I have told you guys what we are going to do, let's understand the parts we are going to be using. So as usual, I told you this is the same car as last week's. So we have our Arduino, we have the same motor shield attached here, and we have the same left and right motors here as we covered in the 2 weeks ago in the part 1 session, where I have attached the motors, the left motors, red and black wires, to pin number 2 and pin number 3 of Arduino, and I have attached the right motors, red and black wire, to pin number 4 and pin number 5 of the Arduino. Okay, this was what we did last week, and we had some more sensors. I have removed those, and we have our battery pack. We have 6 AA batteries that are going to provide a total of 9 volts to our Arduino using this power plug. Okay, so we have all of this. Now additionally, what we are going to be requiring in today's session is we are going to be needing something called a servo motor. I'll tell you what a servo motor actually does and how is it different from the normal DC motors that you see are attached here. Okay, so we have these DC motors, and this is called a servo motor. This also runs on DC current, but servo motor has a specific functionality that is not available in these motors that you see below. I'll tell you guys what those are. Now, other than that, we are going to be using something called an ultrasonic sensor. Okay, so and let me just explain what ultrasonic sensors do. So ultrasonic sensors, so in our previous video, in the part 1 of the video, we had covered IR sensors, infrared sensor. Now infrared sensor, what they do is, you saw that there were 2 LEDs. One was an IR LED, one was a photodiode. So IR LED was firing infrared light, and the reflected light was being sensed by the black colored photodiode. Okay, so similarly, an ultrasonic sensor has it fires sound waves rather than, so infrared is basically a wavelength of light. Okay, on the other hand, we have, one second guys. Yeah, awesome, cool. So on the other hand, ultrasonic sensors, they fire ultrasonic sound wavelengths. Okay, so ultrasonic basically means faster than the frequency of larger than 20 kilohertz of frequency. Okay, ultra means larger than a certain frequency, and infra means lower than a certain frequency. So you will notice that you have lights of wavelength of lights of frequency of ultraviolet and infrared, because among the visible light that you see, you have ranging from colors of red to violet. You have your rainbow, where the rainbow starts from violet to red. Yeah, I'm guessing you guys have learned that the pattern in the rainbow, you call it Vibgyor, Vibgyor. So it starts from violet and goes till red. Yeah, so it starts from violet. Violet has the largest frequency, highest frequency among the visible light that we can see, and red has the lowest frequency of the light that we can see. So there are other frequencies and wavelengths of lights like infrared, that's lower than the frequency of light. Okay, sorry, lower than the frequency of red light, infrared. So we can't see infrared light. Similarly, we can't see ultraviolet light. Ultraviolet light is used in your RO to kill bacteria and everything, kill bacteria and germs to purify your water. So ultraviolet has frequency larger than violet. So similarly, we have ultrasonic sensor. Ultrasonic jets are also there, which fly faster than the speed of sound. So similarly, we have ultrasonic sensor. What one sensor does is this sensor fires a sound that we can't hear, but it fires sound larger than 20 kilohertz of frequency, because 20 kilohertz is something that max that we can hear. Now, it fires ultrasonic sound, and whenever the sound reaches an obstacle, the sound gets reflected back. And the second part of the speaker here, this sensor here, this detects the amount of reflected sound. So now, because the sensor knows that sound travels at a specific speed, so what it can do is it can calculate the time difference between which sound was fired from one of the sensors and sound was received from one of the sensors. Now we know that speed is equal to distance divided by time. So because the sensor knows the speed of the sound waves, and sensor knows the time after which the sound reflected and came back to itself, so this sensor is able to calculate the distance of the obstacle from itself. Okay, so now that it's able to calculate the distance, what it does is we can check, we can tell our car that if the distance is, like, let's say less than 15 centimeters or 20 centimeters or 50 centimeters, then stop moving and check for obstacles on the left or right side. Okay, and once and then calculate the similar distance of obstacles on the left and right side, and depending on wherever it has more space, it will turn to that side and move in that direction. It's as simple as that. It's going to be a very simple lesson. Yeah, so it's going to be a very simple lesson today, but I'm guessing you are able to follow the basic idea of how an obstacle avoiding robot is going to move. Yeah, all you have to do is use an ultrasonic sensor and then write the code. See, this is going to calculate the distance on its own. So you don't even have to calculate the distance. You just have to tell that if the distance calculated by this sensor is less than a specific limit, like we don't want the car to reach an obstacle within a distance of 15 centimeters. So if the distance calculated by ultrasonic sensor in front of the car is less than 15 centimeters, then stop moving, turn to the left and turn to the right and check the obstacle distance on its left and right side, and wherever it has more space, turn to that side and move in that side. Simple as that. Just going to be really simple. So now you guys can see an ultrasonic sensor. So I have it here. I'm just going to show this to you. I'm just going to zoom in. Yeah, so you will see that an ultrasonic sensor has 4 pins. Okay, so 2 of these pins are power pins. It needs a power supply of positive and ground. So 2 of these pins are power supply, and 2 of these pins are for each of these sensors. Okay, so one is called a trigger pin, one is called an echo pin. So trigger pin, whenever a voltage is supplied to the trigger pin, it fires a sound wave, and then the echo pin detects the sound wave and supplies the data from the echo pin. Okay, and those pins are labeled here. Let me just zoom in more. Yeah, I'm not sure if you guys can see that, but all the pins have some words written on top of them. Okay, let me just focus. Yeah, all the pins have some words written on top of them, and you can tell which pin is the trigger pin, which pin is the echo pin, which pin is the ground pin, and which pin is the power supply pin. So all we have to do now is we just have to connect our sensor to the Arduino and define those pins. Okay, so it's going to be really simple as that. And yeah, that was about Arduino. Other than Arduino, I told you we are going to be using servo motors. So what is a servo motor? Now you will notice that in the last class we used something called DC motors, right? So DC motors, what does DC motor do? What does a motor do? Okay, so motor, I'm just uh, I'm not guessing you guys are familiar. I'm guessing you guys are not familiar with the concept of electromagnetic induction or magnetism, but well, electricity and magnets, they um elect- uh, electricity and magnetism, they are correlated. You can make something magnetic by make uh, there are certain objects that can be that can become magnetic when you supply electricity to them. Okay, and then there are certain objects that are already permanent magnets, like you have at your home. So now DC motor, what it does is it takes an electricity and it provides you with a mechanical output. Yeah, so DC motors take in electrical energy and provide you with a mechanical output, mechanical energy. It converts one form of energy into another. How that happens is because you're supplying electricity to the DC motor. Now DC motor has those materials inside them that I told you. When you supply electricity to it, it becomes magnetic, and when you turn off the electricity to it, it becomes non-magnetic. So now AC current. Why am I getting into so much details of AC and DC? But ignore that. Ignore that. It's just that inside the DC motor, electricity keeps on turning on and off again and again. Because of which the magnetic material becomes becomes a magnet, then loses its magnetism, then becomes a magnet and loses its magnetism. And as a result of that, turning the magnetism on and off, there is a permanent magnet inside that ends up rotating again and again. Because you would have noticed that when you bring two magnets together, and if they are of same poles, they repel each other, and if they are of the same pole, then they attract each other. So you have multiple magnets placed with opposite poles, and there is an electromagnet that, because of those permanent magnet, it keeps on rotating when you supply electricity to the electromagnet. Okay, so I got distracted. Ignore everything I was telling you about DC motors. All I wanted to say was, when you supply electricity to a DC motor, it starts turning at a constant speed. Okay, and the moment you supply more electricity, depending on it will increase its speed. If you supply less electricity, it will lower its speed. Okay, but so here in DC motors, you can't control how much angle a specific, like let's say you want to say, I just want my wheel to rotate by 90 degrees. You can't do that using a DC motor, because here you can't control how much okay, someone is saying I'm not audible. Someone is saying I'm not audible. Okay, cool. So I'm guessing now I should be audible. So all I'm saying is, if you were using a DC motor, and then you wanted to say to this DC motor that I just want the wheel to move by 90 degrees, you will not be able to do that, because you can't control the angle that you want to rotate something using a simple DC motor. So for that, we use something called a servo motor. This does the same thing. You supply electricity to a servo motor, and then this white thing here, it rotates. It rotates just like this thing rotates, this pink thing rotates here for a DC motor. Okay, it rotates. But the benefit of a servo motor is because it's made using something called an actuator. You don't have to worry about that, but you can control amount of angle a servo motor rotates by 1 degrees. Like I can tell it to rotate just by 1 degree, I can tell it to rotate by 2 degrees, 3 degrees, 4 degrees, and it will rotate by that much angle, and then it will stop. So the benefit of using a servo motor here is going to be, we will attach our sensor to our servo motor, and then we can tell our servo motor to rotate by 90 degrees to the right and to rotate by 90 degrees to the left, and check the distance. That is going to help us find out how much space this car has in its right and left side. Okay, Awesome. Cool. So simple as that. So all you have to do is, I have the same setup of Arduino batteries here. Don't worry about this extra plate. I just wanted to add a space here, so I have added some spacers. You don't need that. You just need an Arduino motor shield on top of the Arduino and a battery source attached to your Arduino. Okay. Once that is done, in front of your car, attach a DC motor, attach a servo motor. Okay. Attach a servo motor. You can do that using a double-sided tape as well. I'm using a frame here to keep it more stable, but you can just add a double-sided tape at the bottom and fix the servo motor. Like it will stand completely still. Now once your servo motor is attached, your servo motors come with these attachments. You can just simply what I'm going to do is, I'm going to use my ultrasonic sensor, and I'm just going to attach my ultrasonic sensor to this servo's attachment. Okay, simple as that, nothing else. You don't have to do anything. Now once we have done this, we have to attach our servo motor and our ultrasonic sensor to our Arduino. That's all we need to do. So now servo motor has 3 pins. Again, one is the data pin that tells how much angle this has to rotate, and the other 2 are power pins. Everything electronic needs at least 2 pins, one positive power supply, one ground, and other than those 2, it will need some more data pins or read or write pins. Okay, so here the servo motor has 3 pins. The wires are always colored, so you have the red wire that is always positive supply, you have the yellow wire that is always the data pin, and you have the black wire that is the ground pin. Okay, so in the last session I had shown all of you that the motor shield here has multiple rows of these 3 pins. All of these pins are ground, 5-volt supply, and data pins. So you just have to attach the servo to these 3 pins of your motor shield. Okay, so right now I'm attaching my servo to pin number 9 of Arduino, the data pin of servo to pin number 9 of Arduino, and 5-volt and ground to the 5-volt and ground of Arduino. That's all. It comes in sets of 3 pins. You can just plug it in, just check the pin number in which you're attaching it. So I have attached the yellow wire of the data pin of the servo to pin number 9 of my Arduino. That's all I have done. And then 5 volts and ground to the 5-volt and ground pin. All of those are labeled here. I'd shown this diagram to all of you in the part 1 video. Okay, so servo motor is attached. Once the servo motor is attached, what we have to do now is we have to attach our ultrasonic sensor. Now ultrasonic sensor again has 4 pins, so it has a ground and 5-volt pin. So ground, again as usual, there are some ground pins here. You can attach to any of these. So I'm attaching my ground pin of the ultrasonic sensor to the ground pin here. And other than that, I have the 5-volt pin, that is my yellow wire here. I have attached my 5-volt pin to the yellow wire here. And I'm just simply going to attach the yellow wire to the 5 volts supply here. Okay, once I have done that, now other than that, you have 2 more wires coming for your echo and trigger pin of your ultrasonic sensor. Okay, who will know that which pins we have attached to the wires? See, all the pins are labeled. Okay, on these circuits, whenever you get these circuits, you will be able to, when you read those circuits, you will be able to see that which pin has what part. Okay, which pin is what activity. Other than that, also let me do something for you guys. I'm just going to I'm going to show you guys something here. I'm going to show you guys an ultrasonic sensor. So whenever ultrasonic sensor, ultrasonic sensor pin diagram. Whenever you use a circuit, whenever you guys use a circuit, don't worry about my camera right now. I'm just showing you guys that whenever you guys use a circuit, you can always Google its pin diagram. Every circuit has a pin diagram that is available on the internet. Okay, so the most common ultrasonic sensor is this HCSR04. This is the one I have as well. You can see on this image here, the circuit has the model number printed here, HCSR04. So whichever model you have, just search for it and you will see that it has all the pins labeled here. Okay, similarly I can search for Arduino Uno R3 datasheet or pin diagram, and it will give me the datasheet. I can Google for each of those parts and I will be able to find out these. So, but these are too complicated to read. That's why I'm just showing you what their basic activities are. You see, there's a 5-volt pin here. There's a ground pin here. So all we have done here is this 5-volt pin is attached to the 5 volts. This VCC here is the 5-volt pin of my ultrasonic sensor, and similarly my servo motor also has a 5-volt pin. So all I'm doing here is, see this 5 volts of my Arduino. I'm using this 5 volt to supply 5 volt supply to my sensor, to supply 5 volts to my to the servo motor, to all the other motors and everything. I'm getting 9 volts of supply from the batteries to my Arduino, and my Arduino is splitting that power up into different is splitting those powers and supplying it to different parts in itself. Okay, so see, all of those things are written. You will know which even when you buy an Arduino, you will have on the front and the back all of these circuits. These are called printed circuit boards. They have the wires printed inside of them, and on top of them they are labeled. Everything is labeled and the data sheets are available on the internet. Okay, Arduino Uno is the computer that we are using to code our game. Sorry, to code our robot. Let me come back to the thing here, and I'm just going to transition to this thing. Awesome. So this blue thing, this is a small computer that is running our car. This is called an Arduino Uno. Okay, it has all the pins numbered here. So that's what I was telling you. So my ultrasonic sensor has a 5-volt pin. I have to attach this 5 volts to the 5-volt pin of my Arduino. I'm doing that. Other than that, my ultrasonic sensor has a trigger pin and an echo pin. So I just need to attach them to 2 of the numbered pins in the Arduino Uno. So as I was showing you, there are a lot of numbered pins. Let me show you again. Let me go through my screen again, and you will see that there are some pins that are already defined, like 5-volt, ground. These pins are already defined, but then you have these pins that are only numbered: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then A0 to A5. These pins are they have their own numbers. We can attach anything to these pins and then define the function of what these pins are going to do. That is the code that we write when we code on an Arduino. Okay? Yeah. So I hope the basic idea of what we code in an Arduino is clear to all of you. What we do is we use these numbered pins. We attach different types of sensors, motors to these numbered pins here. Okay, and then we define these pins have nothing defined. So because see, Arduino is a small simple computer. It doesn't have just like, okay, understand this. I was telling this to you guys last class as well, so I'm going to tell this again. When you buy a desktop or a laptop, okay, then what do you do is your computer already knows that your keyboard is an input device, your monitor is an output device, your mouse is an input device. It means that it has to take input from the mouse by moving the mouse pointer. It has to take input in terms of text or number from the keyboard. Those things are already defined for your laptop, for your computers that you buy. But for Arduino, because Arduino is a very basic computer, those things are not defined. So what you can do is you can attach these pins to any sensor you want, and then you can define, you can write in the code whether to get input from those pins or whether to supply output to those pins. Okay, you see, like 2, 3, 4, 5, 6, 7, 8, 9, 10. So like our ultrasonic sensor. Okay, our ultrasonic sensor has a trigger and an echo pin. Trigger pin needs to is an input pin, and echo is an output pin. What it means is echo pin needs to get data from outside and give it to the computer. Sorry, echo is an input pin and trigger is an output pin. Echo takes input from outside, yeah, and trigger supplies output. Trigger supplies voltage so that it can fire 5 volt, it can fire the sound waves. And whenever the sound wave returns back, the echo pin takes in that input. Okay, so you have to define now, you can attach trigger and echo to any numbered pin of your Arduino, and then you can define them to be input and output, and define their functionality. That's what we code when we start coding the robot. All right, so let me just come back to my thing here, and let me just let me just attach everything so that we can start coding, and I'll show you how the code works. Okay, so as I was telling you, I have attached a blue wire to my echo pin. So I'm attaching the blue wire to now pin number 7 of my Arduino. Okay, the pins are numbered. I just showed you guys that the pins are numbered. So I'm just saying I'm attaching trigger pin of my ultrasonic sensor to pin number 7 of my Arduino. And then I'm attaching the echo pin to pin number 8 of my Arduino. Okay. So those things, I can choose where to attach which pin. And now I'm attaching the 5 volt supply to the 5 volts of my Arduino. Done. Our connection is done. We have connected our servo to pin number 9, the data pin of servo to pin number 9, the echo pin of ultrasonic sensor to pin number 8, and trigger pin to pin number 7. And then rest are just 5 volts and ground supply. So we have connected them to the 5 volts and ground pin. That's all we have done. Okay. So now we are going to code this. Okay, but before we code this, since I have the code added, my voice is low. Okay, I'm so sorry, I have confused a lot of you this session, so I just watch. Over time you guys will understand what I'm talking about. I have the code of obstacle avoiding thing running already uploaded to my Arduino right now. So I'm just going to show you guys first of all how it works. So I'm just going to add the power supply here, and I'm going to, so I have an obstacle here. I'm just going to show you guys how this works. I'm going to turn on my Arduino. See, okay, so you guys saw that because it detected an obstacle in front, it turned right and moved. So there was a drop here, there was an obstacle here, the largest distance available for it to go was here, so it went that side. Okay, want to try again? So right now I won't have any obstacle in front and it will go in front. Oh, I think my, yep. Yeah. Actually, my right side motor is kind of, one second. So actually the wire of my right side motor has come out. Just don't worry. So, but basically you guys saw, right, what it's supposed to do. So when it detects an obstacle in front, it's just going to check on the left and the right, and then move in that direction. Ignore the motors, ignore the wheels. Just so yeah, when it detects on the front, then it turns left and right, and it checks that, and then yeah, it turns in that direction. Otherwise, it moves forward. Okay, now this is a small table here, so I'm not, and this is a big thing, and it's a small table, so I'm not trying to break anything here, but I hope you get the idea of how this is supposed to function. So now we can start coding, and I'll show you the code of it. Okay, so let's go to scene 2, and studio mode, fade, scene 2. Okay, yep. So now you guys can see that I have the code of my car already added here. Okay, so I'm just going to show you guys. It's a long code. It's not that long, but it's still a long code. So I have written the whole thing. I'll explain the entire code to you, and I'll show you what we have done here. So yeah, as usual, ignore these 2 lines of code right now. Actually, let me just open up a new sketch. So yeah, this is an Arduino's IDE. Arduino's IDE, Arduino IDE, as you guys can see here. If you just last class, I was having difficulty showing you guys how to download it, so I'm just showing you Arduino. If you guys just Google Arduino IDE, then you guys will get this link here, and you guys can open up this link, software Arduino, and then download the IDE. A lot of you guys were asking in the previous session whether we can use VS Code or not, whether we can use other code editors or not. You guys can use VS Code editors and Sublime Code Editor or things like that, but to do that, you'll have to add certain extensions. So there are lots of things we can do on the Arduino's code editor that you can't do on VS Code or Sublime Text Editor and things like that. So, but they have extensions available, and there are some rules regarding how. There are some rules regarding how can those VS Code or Sublime Text Editor works. Okay, so you'll have to search for the. You'll have to read first of all on how to code for an Arduino on a VS Code editor or Sublime Text Editor, and understand the restrictions, install the proper extensions, and then you guys will be able to use VS Code editor or Sublime Text Editor or Atom Text Editor to code for an Arduino. Otherwise, it's a very simple thing. You guys can just download this Arduino's IDE and code the whole thing on the Arduino's IDE. It's very simple. So I have the Arduino's IDE open up here. Okay. Yeah, it's free. The IDE is an internal development environment. IDE is where you guys can. So there are things like, let me show you. IDE. Array, yeah, not translation. Yeah, sorry, integrated development environment. Okay. Now there are different types of code editors. They are basically code editors. You guys have Microsoft Visual Studio, Atom, all of these things are different types of code editors on which you can code anything you want: HTML, CSS, Python, all of these things. So these are softwares on which you can code your stuff. Okay. So you guys can download these. These are called IDEs, integrated development environments. So Similarly, for Arduino, we have an Arduino's IDE that you have to download and install on your system to be able to use Arduino's thing. Okay, so now I have the Arduino's IDE open up. Okay, so when the Arduino's IDE opens up, you will see this very basic layout of the code here that has two functions called setup and loop. Setup function runs once, and then loop function is something that runs again and again. So anything you write inside the loop function is going to run again and again and again and again. Okay, and whatever you have in the setup function is going to run once for the very first time your for the very first time your code is loaded. Okay, okay, just give me 1 second. Yeah, I think my camera will not be visible in the dark side here, so let's just ignore my camera for the time being. And yeah, it's going to be a black thing there for some time, ignore that. Or I'm just going to hide my camera from this scene here. Delete, yes, and fade. Awesome. Okay, so this is an Arduino's IDE, and what we can do here is now we start with, first of all, as you can see in the code that I have here, we start with defining the variables for our pins. So I told you guys that we have added the motors left and right motors to pin number 2, 3, 4, and 5 of our Arduino. So that's all I'm defining here. I'm defining variables just like we define variables in JavaScript in any other programming language. We are defining variables, and we are giving names to our pins, names that I can use, I can understand on my own. Okay, so pin number 2 is attached to the red wire, the front wire of my left motor, so I have named it motor LF. Pin number 3 is attached to the black wire of my motor, so motor LB. Pin number 4 of the Arduino is attached to the right motor's front wire, red wire, positive wire, so motor RF. And pin number 5 is attached to the motor right motor's black wire, so motor RB. That's all I'm doing here. I'm defining I'm giving pin numbers that I'm using variable names. Okay, yeah, so this is something we did in previous session, defining these 4 pins, and yeah, this is the 4 pins, defining these 4 pins we did in previous session, so we are not going into details about that. Now, since we are using 2 new things called servo and ultrasonic sensor, we can directly code stuff about servo motors and ultrasonic sensor as well, but just like in JavaScript and Python and everywhere, you have libraries available of pre-defined codes and functions that you can use on different sensors. Similarly, we have libraries available for Arduino as well. So there are 2 libraries called, so there is this one library called servo.h. .h is a header, it's called .head, it's a header file. Whenever you use a servo in your, whenever you want to write a code to manipulate the action of a servo motor, you have to include a servo.h file. So we do that like this. We write this hashtag include, and then we write it servo.h inside these greater than and less than symbol. Okay, and similarly for my 1 second. 1 second, guys. Yeah. So similarly, we have for the ultrasonic sensor, there is a library called new ping. Okay. So we just write this. This code is also going to be available in the video's description after the session. Okay, I will upload this code. You can download the zip file of this code and study the code as well. So if you guys are not able to follow everything of the code that's written here, don't worry about it. All of this, sorry, just come back after the video is over. Just look at the video's description, and this codes file is going to be available in that. All the Amazon links are going to be available for each and every part that I have shown you. All of those are going to be available in the video's description. Okay, so as I was telling you, we have to attach two library files, header files. One is called newping.h and one is called servo.h. Now sometimes if you're, see, this is orange here, it means that I have the library installed. If it's not orange, it means I don't have the library installed on my system. So to install a library, what you do is you go to the sketch menu here, and then there is an option called include library. You click on include library, and then there is a manage library option here. Click on that. And what you can do is this will open up a manage library menu like this. Okay. So whichever library you want to install, you can find those libraries here. So if I wanted to install newping, I can search for newping. This will search for newping library, and you can see that I am able to see the newping library here, and it says that it's already installed. So the install button is deactivated. But if you guys don't have the library installed, then you can just install it from here. Okay. So servo.h and newping, these two libraries are attached here at the very beginning of our code. Now, after we define these motor pins, we are defining the ultrasonic sensors pin. Now, the way to define them is a bit different because we are using a library for those. So we say define, and then give the pin a name. So I know I have attached pin number 7 to my echo pin. So I'm giving it the name echo itself so that I can understand it. And then I'm defining trigger pin at pin number 8 like this. Okay. So you have to say hashtag define, then give the pin a name, and then for the ultrasonic sensors library, and then pin number. Okay. And same goes for your second pin that I'm naming it trigger pin. Okay. So once you do that, now what we are doing is we are keeping track of how much distance our car is going to have on its left side, right side, front side. Okay. So we are defining 3 new variables. I'm just calling them front D, left D, and right D, and giving them initial values of 0. Just like we define variables in any other languages, in JavaScript, Java, C, C++, Python, everywhere. Similarly, we are just calling it int front D is equal to 0, int left D is equal to 0, int right D is equal to 0. Okay. And then I'm just keeping writing a variable, defining a variable to store what is the maximum distance I want between any obstacle and my car. So I want at least 50 centimeters of space between everything. So I'm just creating a variable called max D and giving it the value of 50. Okay. So now that this is done, what we are going to do is we are going to define our ultrasonic sensor and our servo. So you have to give your servo a name. So to give your servo a name, you just write the header file's title here. So capital SERVO, the same name that you have written here. You start with that. It will be orange if the name is correct. And then give your servo a name. So I'm just giving it a name servo 1. Okay. And similarly, for I have to define in my code that there is something called an ultrasonic sensor that exists. So to do that, I'm just writing this same new ping, the file that I'm defining here, the header file, new ping, and then give your sensor a name, and then tell it what is the name of the trigger pin and what is the name of the echo pin. So those are defined here. So trigger is basically pin number 8 and echo is pin number 7. So that's what I'm defining here. Okay. So this is how you'll have to write those things. And then you can ignore this variable. We don't need this variable. I was just testing it out something. Okay. And this also you can ignore. I was testing that as well. So now we come to our setup function. Yeah. So as you can see, we have a setup function that runs at the very beginning when the code is uploaded on our Arduino. So in the setup function, we are defining, as we did in the last session, we are defining what are, so as I told you, Arduino doesn't know which pins are output, which pins are input. Okay. So we are defining here that pin mode of all the motor pins are output. Okay. So this is we did this in the last session. We defined pin mode of motors. All the motors pin are output pins. So our Arduino needs to know that those are output pins. So this is how you define that. Okay. And then I had deleted this pause variable. So I'm just going to, yeah. So then I'm defining that my servo is attached to pin number 9. See, nowhere in my code right till now, I had defined where my servo is attached. I had attached my servo to pin number 9 of the Arduino. So I'm saying name of the servo dot attach to pin number 9 to 9. That means that my servo is attached to pin number 9. And then I'm saying servo 1 dot write 90. This means that go to the angle of 90 degrees on. So on a servo, let me come back here. Let me come back to the scene here. And well, let me, yep. Yeah. So these pins, the servo here, it has the angles defined in itself. So this is 0 degrees. It's right now it's looking at 0 degrees, and then it has 0 to 180 degrees. That's how much my servo can rotate, from 0 to 90 degrees. Okay. But since at the very beginning when the car starts, your servo can be at any angle. So what I'm saying is, by default, when the code starts, come to the 90 degrees angle, because that is going to be your front portion. Okay. So that's what I'm telling my code here, that servo is attached to pin number 9. Now come to the 90 degrees angle. Okay. And then it's going to stay at the 90 degrees angle. Okay. So now 90 degrees angle, and then I'm saying before it goes to the loop function, just wait for 1 second. So there is a delay, this line of code called delay 1000. This pauses your computer to ask your computer to wait for like 1000 milliseconds before going to the next line of code. So I'm just saying that because now loop is going to run again and again multiple times, and my servo might take some time to go to this 90 degree angle. So after this line of code runs, wait for 1 second in which my servo is going to rotate, and after it waits for 1 second, then it starts running the loop function that is going to run again and again. Okay. So now before we go inside the loop function, this is very simple. So as we did in our previous session, we had defined functions of how our car is going to move forward. So for it to move forward, we had defined a void forward, and inside this what we had done is we had said that Arduino is going to supply high voltage to the red wires of my left and right motors, and Arduino is going to supply low voltage to the black wires of my both left and right motors. That way my Arduino is going to move forward. Okay. Sorry, my car is going to move forward. Yeah. So, oh, you can't see my screen. I'm so sorry. I should have done this. Wow. That's why I'm thinking that you guys are only seeing my robot there. Okay, no worries. My screen should be visible now. I'm so sorry. So yeah, let me just recap again. We have this delay. We were at servo is attached to pin number 9, and we are saying come to the middle of come to the middle by coming to the 90 degrees angle, because your left is going to be 0 degrees and right is going to be 180 degrees. Okay, so center is your 90 degrees, so I'm saying stay at the 90 degrees angle at the very beginning, and then wait for 1 second before running everything else. Okay, after that what we are doing is I'm defining some functions to make our car move. Yeah, so to make our car move, as we this is the same thing. I wrote these functions in the previous session of part 1, so you guys if you guys watch that, this will be easier to follow. To make the car move forward, I'm saying supply high voltage to both the red wires of both my motors, left and right motor, and supply low voltage to the black wires of both my motors. That is going to make my car move forward. Okay, and then to make my car move right, what we are doing is we are turning off the right motor completely by supplying low voltage to both the red and black wires of my right motor, and then we are just turning the left motor forward. So as a result of this, I had showed you guys in the previous session that our car will end up, when these lines of code run, as a result of these 4 lines, our car will end up turning to the right. So I have this turn right function. And similarly, to turn left, I have turned off my left motor completely and just moving the right motor by supplying high voltage to the red wire and supplying low voltage to the black wire of the right motor. Okay, so yeah, we had done the forward, right, and left functions in our previous session. So what we are going to do in this new session today here is, first of all, I have defined 2 new functions. I have defined a move back function. Okay, that is completely opposite of the move forward function. Okay, so in move forward, to make our car move forward, what we were doing was we were supplying high voltage to the red wires of both left and right motor, and we were supplying low voltage to the black wires of both left and right motor, and as a result my car was moving forward because both the wheels were rotating in the forward direction. Now to make my car move back, because what will happen is we want our car to move back when there is no space on the right side, on the left side, and on the front as well. Yeah, then we want our car to move a bit back and then check for distances again on the left, right, and the front. Yeah, so to do that, we are writing a function that is going to make our car move back. And to move back, all we have to do is supply low voltage to the red wires of both my left and right motor, and supply high voltage to the black wires of both the left and right motor. As a result, my wheels will move backward and the car will move backward. Okay, simple as that. Yeah, I know you guys won't remember this, but you'll be able to, you will have, the code will be available in the video's description. So you guys can, download the code after I have uploaded the code in the video's description, and you guys can go through the code while you are watching the video, and you will be able to follow exactly what is happening in the code. Okay, and then we have a stop function where we are just completely stopping our car. So for that, low voltage is supplied to all the 4 wires, red and black, of the left and right motors. Okay, so done. Stop function is defined. Now after that, we have some new functions here. So let us go back to our scene here, and let me discuss with all of you guys. Oh, I don't have my pen with me. Give me 1 second. Let me bring my pen, and I would like to just talk to you guys about how we are going to make our car turn. Okay, yeah. So now what I want to show you guys is, see, how are we going to make our car turn? Okay, so let's say, yeah, so we have a path, okay, and we have a path like this. So, and our car is here. Okay, this is our car and it's facing forward like this. I'm just going to ensure my, yeah. So my car is facing in the forward direction. So I have my two sensors. I have my ultrasonic sensor here. Okay, I have my ultrasonic sensor here, and what we want to do is, my ultrasonic sensor, once it detects that there is not much distance in front of it, then what it will do is it will stop the car. Then this sensor has to turn to the left side and the right side and check the distance on the left side and on the right side. Yeah, so our code is just going to reflect that. Yeah, so let us go back to our code, and this is going to be really easy to code now. Yeah, so I have defined a function called get distance, get d. Okay, so all this is doing is this will first turn the motor to the left side, to the right side. 0 degrees is making my motor turn, making my ultrasonic sensor turn to the right side. So I'm saying servo.right to 0 degrees. So turn to the right side, and then it's going to take some time to turn. So I'm adding a delay of 500 milliseconds. And after it has turned to the right side, then check the distance, calculate the distance and store that in the right d variable. Remember, we had added 3 variables here for storing our distances: front distance, left distance, right distance. So I'm just saying turn the motor to the right side by going to 0 degrees angle, turn the servo motor to the right side by going to the 0 degrees angle, and wait for 500 milliseconds, half a second, because we are adding this delay because our motor will take some time to turn. Okay, after it has turned, then store the distance. So how do we calculate the distance using our ultrasonic sensor? So our ultrasonic sensor has a function called ping underscore centimeter, cm, followed by round brackets. So just like in hatch XR, you have functions like setx, getx, setY, getY. Our this new ping.h library that we added at the top of our code, this has a function called ping underscore centimeter. And see, I have given the name distance sensor to my ultrasonic sensor. Just like in hatch XR, what do? We, to make an object, like to make a rocket go up, we say its name rocket dot, then to move up set y. So set y is a function that is inside hatch, and rocket is the name of the object. Similarly, I have name of my sensor. So I have distance sensor is the name of my sensor dot, and then we have the name of the function. So to calculate the distance, our new ping library also has a function called ping underscore centimeter. So I will let me show you something else. So whenever you're using these new libraries, you guys will ask me like, how do I know these functions exist or not, and all of these things. So Google. Everything is available on Google. I want to learn about this new ping library. I'm just going to search for newping.h. Okay, and on GitHub everything is available. So if I open this file up, newping.h on GitHub, see, this tells me how to define a function, how to define this a sensor. You write new ping followed by the name of the sensor, followed by the name of its trigger pin, followed by the name of its echo pin. So that's exactly what I have done in my code here. I have said new ping followed by name of my sensor. I gave it a name, distance sensor, and then the name of my trigger pin is trig, that I have defined here, and the name of my echo pin is echo, that I have defined here. So I'm writing those names here. I can once I read these, the way new ping.h is supposed to work, I know how to use that in the code. Okay, all of this information is available on the internet of how to use any new library. So I'm just showing you guys this new ping library. Now, what are the functions available in the new ping library? It tells me here, see, it has a function called ping that will tell you in how much time the sensor is detecting the sound coming back to it. Okay, and then there is a function called ping_in, in. This will tell you the distance of the obstacle from the sensor in inches. It's written here. And similarly, you have another function called ping_centimeter. This tells you the distance of the obstacle from the sensor in centimeters. So I'm using this ping_centimeter function. So I'm just saying here that whenever I want to calculate the distance, check the distance of my car with on all sides. First, turn the sensor, ultrasonic sensor, to the right side. So to the right side, the angle is 0. So servo 1.right is 0. Wait for like half a second, and then calculate the distance. So right distance is, because it's already turned to the right side, just the right distance is equal to name of the sensor dot ping_cm followed by round brackets. Okay, once you have found out the right distance, then move the servo back to the front, servo.right 90. Okay, whenever you move the servo, just add a delay so that there is no overlap of code. So once my servo turns to the front, it waits for half a second, and now 90 degrees means front, so I'm storing the distance in the front d variable, and then I'm saying that move to the left side by going to the angle of 180 degrees, and then wait, and then store the distance in the left d variable. Okay, and then move back to the front. Do this much. Once it does this much, then go back to the front. Yeah, so once this is done, now I go back to my loop function here. Yeah, so this is my loop function. Oops. Yeah, so this is my loop function here, and now see, every time my loop function is by default going to run again and again and again and again. Okay, so all I'm saying is, every time my loop function runs, calculate the distance in front of my car and store it in the front d variable. Okay, once it stores the distance, if the front d variable's value is less than the maximum distance that I am defining, I have defined the maximum distance here as 50 centimeters. See, so if the front d value, the distance in front, is less than the maximum distance, then stop the car and get the distance on the left and right side using the get d function, the one that I just described to you. This get d function tells your car will calculate the distance on the left and right side. Yeah, so if the front distance is less than the max distance, then stop the car. then find out the distance on the left and right side. Now, if the right distance is greater than the maximum distance, then you can turn to the right side and move forward. Okay? Or if the left distance is greater than the maximum distance, then turn left and then move forward. Okay? But if neither the left and the right distance is greater than maximum distance, then make the car move back and then stop the car, and then it will and then stop the car, and then what will happen is it will then check the distance again using the get d function. Otherwise it will keep on moving forward. Okay, so that's all the code is telling you here, that continuously keep on checking the distance in front of the car. If the distance is less than the maximum distance, then find out its distance on the left and right side. If the right side distance is greater than the maximum distance, then turn to the right and move to the right. Or if the left side distance is greater than the maximum distance, then turn to the left and move to the left. But if neither of left and right distance is greater than the maximum distance, then make the car move back and then check again on the left and right side, and then move the car. Okay, that is that. Now, once you have written the code, I had missed showing you guys this in the last session, so let me show you guys. So you have this tools button, tools menu here, where you have to define your board on which you want to upload this code. There are multiple types of Arduino board, as you can see from the list here. So in the tools menu, you have to select which board you have on which you want to add the code. So I have an Arduino Uno board, so I'm attaching, I want to upload it to Arduino Uno. So I select my Arduino Uno board. Okay. Other than that, you have to go to the tools menu and select which port of your computer is the Arduino board attached to. So right now I have not connected my Arduino board. So for that, I showed you guys that there is a cable available. You can use that cable, and I have the cable with me. Now when I attach this cable to the Arduino, you will notice that, one second, yeah, see, now my Arduino is attached to the port, so it automatically detects which port is connected to the computer. Okay, and it will tell you that you just have to select this port here, and once it's selected, now you compile your code first by clicking on this tick mark. Okay, and then you compile the code. If there are no errors, it will say done compiling and no errors. Then you can upload your code by clicking on this upload button to your Arduino. So this will upload your code. Okay, once that has happened, then I am going to show you guys what it looks like. So you can see, so right now I'm just going to disconnect the cable now from the computer, and now to run our car I just have to connect the battery source. So I just connect the battery source. Let me just fix the right motor here. It broke, so it might not function exactly the way I want, but it should function adequately for the meantime. So I have connected the wires properly, and I'm just turning on my car. If there is no obstacle, it will move front. I'm turning on the car. It will move front. So now it detected an obstacle in front, so it stopped. And every time it detects an obstacle, see, it turns to the left and right, and then tries. I'm holding my car here, so it's not turning, but See, I'll drop the car, so it turned now. Because it found that there is no obstacle on the right side. Here on the left side, I'm sitting here. So it's detecting that there is an obstacle on the left side, there is an obstacle in front. So it's trying to move to the right side. Sorry. Okay. Actually, let me see if I can show you guys this on a different system. On here, I'm just going to use my I'm just going to use my this here, and I'm going to put the car on the floor. Let's hope that works. Okay. I'm sorry for such a bad camera quality, but let's see. So there's my sofa there, and if I put the car here, it moves, it stops, it turns to the right, it moves, it will turn to the left, and it moves on its own. See? Yeah. So let's do that again. Okay? Front. And then it should turn to the right. It should turn to the turn left. Okay, yeah, turn right. Yeah, now turn right. Now turn up. So this is this has a very low clearance, so it's not detecting that. Okay, but you guys are getting the idea of how this is working, right? I should just So I just hope you guys are getting the idea of how this whole thing is connected, how this whole thing works. I hope I hope I was clear. You guys are bored. So we are at the end of it. So yeah, we can end the session now. Just 2-3 things. Everything is going to be available in the video's description. If you want to watch it again, check the video's description after half an hour. All the code, all the parts, every link is going to be available in the video's description. You can download everything from the video's description. Check out part 1, where we learn how to build the entire thing, as well as how to make the car follow a specific path. So now what you can do is, you can code a car, you can combine the code of part 1 and part 2 and write a code so that your car follows a specific path, but then when it reaches an obstacle, it avoids the obstacle and then comes back to the path and then follows the path again. So when you self-driving cars have similar logic, but it has then AI built into it so that it can decide how much to turn and everything. This will be the very simplified concept of what a self-driving car should be like. There are lots more stuff of AI neural networks attached to that. So that's that. And what else? What else do we have? I have lots of stuff we can do with Arduino. I can show you guys, but I am going to try something fun 2 weeks after. Next week, Niharika is going to take, you're going to have Squad Wars. I was told that you're going to have Squad Wars. It's something that apparently you guys like of Camp K12. And so next week, you're going to have Squad Wars. Come for that. Have your squads ready. I'm not sure of the rules. Rules might be displayed in the description of this video as well, or on Discord. Just every community you're a part of, rules are posted everywhere, just either Insta or Facebook or for students, I'm guessing mostly on Discord. So be aware of the announcements on Discord. Or there are some competitions as well on Facebook right now. I was told that's going on. Those details are also going to be available in the description of the video. I'm not sure of all of this. Just read the description, you will get everything. Discord, Facebook, Insta, Twitter, all of those things. Cool. Chalo. Bye bye. Next week, Squad Wars by Niharika, and then the week after that, let's not try robotics, let's try something different. Yeah, let's try something different. Yeah, cool. Bye bye. I'm gonna end the stream now.